Good day everyone. So in this video lesson, we will tackle about discrete and continuous random variable. These are the two types of random variable. If we say discrete random variable, it is a random variable that can take on a finite or countably infinite number of distinct values. It is all about counting data. Mostly discrete random variable is a whole number. We have here two examples. Number 1, the number of siblings a person has. 2, the number of students present in a classroom at a given time. So, tandaan class, kapag discrete random variable, it is a finite or countably infinite. So, let us proceed to continuous random variable. A random variable that take an infinitely uncountable number of possible values, typically measurable quantities. So, it is about what? It is all about measuring data. A random variable that represent a measured data. Mostly, ito yung sinusukat. Measuring height, weight, pagkuha ng time, distance, amount. It is all about measured quantities. We have here 3 examples. First, we have numbers of stars in galaxy. We can't count stars in the galaxy, right? Second, the height or weight of the person. Third, body temperature. So always remember that continuous random variable is about measuring data. Let us first look at the graph and determine which one are discrete and which one are continuous. So if the points are connected between in the start and in the end, it is a continuous random variable. And if it is not, it is a discrete. We have here number 1. Is it discrete or continuous? It is continuous. Number 2. Obviously, the points are not connected. It is discrete. Number 3. Just like number 2, the points are not connected. It is also discrete. Number 4. It has an arrow and it is connected. It is continuous. Let us proceed here. Classify each random variable as discrete or continuous. We have here number 1. Scores of students in a quiz. Is it discrete or continuous? It is discrete. Number 2. How long students ate breakfast? Is it discrete or continuous? It is continuous. Why? From the word how long, it talks about time. Number 3. Time to finish running 100 meters. Is it discrete or continuous? It is also continuous. Number 4. Amount of paint utilized in a building project. It is also continuous. From the word itself, amount. 5. The speed of a car. It is continuous. That's all. To tackle about the levels of measurement, let us give the floor to Miss Laika Corbita.
Hi everyone, my name is Laika Corbita and I'm going to explain to you the 2 of the 4 level of measurement, which is the nominal level and the ordinal level. Nominal level of measurement classifies data into mutually exclusive or non-overlapping categories in which no order or ranking can be imposed on the data. Nominal scale is the naming scale where variables are simply named or labeled with no specific order. For example, the variable hair color could be measured on a nominal scale according to the following categories, which are the blonde hair, brown hair, or the gray hair, and so on. We have here some examples of nominal data include eye color, color sa imong mata like blue, brown, green, or nationality. We have German, Lebanese, or American. And we have marital status like married or single. Gender, we have women and men. When using the nominal scale, bear in mind that there is no order to the groups you can use to classify your variable. One category is not higher than, better than, or greater than another. We have here the ordinal level of measurement. The second level of measurement is the ordinal data. It classifies data into categories that can be ranked. However, precise differences between the ranks do not exist. The ordinal level of measurement is more precise than the nominal scale. It's still a qualitative measure and thus not as precise or informative as the interval and ratio scales. Here are the examples of ordinal data. We have here the academic grades like A, B, C, and so on. We have income, high, medium, or low, but note that income is not an ordinal variable by default. It depends on how you choose to measure it. We have education level like elementary, high school, and college graduate. As it clear from our examples, the ordinal scale naturally ranks variables into a meaningful or order or hierarchy. That's all.
In this video, we will discuss about interval scale. What is interval scale? Interval scale allows us not only to rank order the items that are measured, but also to quantify and compare the difference between values. The interval scale doesn't have a well-defined zero. In other words, we cannot talk about ratios with an interval scale. For example, when the weather outside is 80 degrees Fahrenheit, we cannot say that it is twice as hot as 40 degrees Fahrenheit. This is because a temperature of 0 degrees Fahrenheit does not mean no temperature. Rather, it means a temperature of 0 degrees Fahrenheit. To summarize, interval scale has following characteristics: meaningful intervals, but not ratios, not to zero. Examples: IQ scores, temperature scale, used by quantitative data. The last level of measurement is ratio data. So, what is ratio data? A ratio data is a quantitative scale where there is a true zero and equal intervals between neighboring twins. Unlike on an interval scale, a zero on a ratio scale means there is a total absence of the variable you are measuring. The ratio level is the highest of our hierarchical levels of measurement. The level or scales of measurement indicates how precisely data is recorded. The higher the level, the more complex the measurement is. On a ratio scale, a zero means there is a total absence of the variable of interest. For example, the number of children in a household or years of work experience are ratio variables. A respondent can have no children in their household or 0 years of work experience. So, what is an example of ratio data? Income, height, weight, annual sales, market share, product defect rates, time to repurchase, unemployment rate, and crime rate are examples of ratio data. As you can see, ratio data is all about measuring continuous variable in equidistant scales. It is important to note that while values in our ratio dataset must be capable of reaching true zero, this is not the same thing as actually having values that go down to zero.